This is Hello World with a test, which is where we left it off with one of the tutorials. The goal here is to introduce a little bit more of the input side of things, just to get basic input and output into your program. So println statements are simple ways to get output from your program. But what if you wanted to do a little more and actually ask a question and use data that the user types in to decide how something works? So the simplest thing I can think of that might illustrate that is maybe to ask someone's name and then say hello to that name instead of just hello world. So just to put it in there, println name. So that's a prompt. So the goal of the prompt is to just make sure the user isn't sitting there wondering why nothing happens. You need to give the user some hint that they're being asked something to provide before moving on. And then to get the actual name back, I think that's probably one of the better choices, is to read an entire line from the user, that is until they press enter, and use that as the string that will then be, instead of world, we're going to go ahead and just print out that name like that. All right, and so I guess just to illustrate it without worrying about any of the tests for the minute, I'll turn that off essentially by untesting it and go. So since it's no longer named test up there, it's not going to run that test. And now I just ask for the name. Oh, interesting, name. And if I say George, no, my name is not George, it says hello George. And actually, a little pedantic, name. I had a space in there just because I tend to like the names showing right next to it. So let's get rid of that and give it another run. Name. Okay, now if I say George, it says hello George. So name, hello George, and it all showed up on one line, which I think might be more compact when you start asking more questions. And it prints out hello George. So print out a prompt, get the response from the user as a string, and then print that out. So let's print out and ask for a number as well. So kind of the same looking pattern. So give the user some kind of prompt, and now apparently we want some sort of number, and read int like that. Print when you chose number, like that. Go. So when I run it now, if I ask for a name, Ada, number, I don't know, 2, and then hello Ada, you chose 2, like that. So there's the very simple illustration of some of the mechanisms for getting input in and out of your program. We haven't done very much with it, but that's the point of just starting. So let's see how hard it is to test setting that up. So here, to get that kind of input and output, we really need to create an input file. So we're creating a file, so it's an output file for the moment. So out, open the file which we want to use for input later. But right now we're writing out to it, and basically each of the, if it's a read line, then up here we'd like to print line. So just to reproduce what's in there, so print line Ada. So that's the response to the first question. And then in response to the second question was 2, so print len 2, like that. So that's the two things that we're being asked about in the program, so we're going to provide those two responses in there, and close that output. Okay, so that's what we want for input. And then now for output, we just have to remember that the prompts are also part of the output of the program. So when you print one question that gets asked asked in there is name with the space, is quite detailed about what it's asking for. It has to match exactly. And then number, question mark, like that. So in the output, we expect to see that there's a name prompt thing, and then followed by a number prompt thing, and then hello world, but now it's going to be hello Ada with that kind of input, and println hello, oops, you chose to. So with that kind of input, you expect that kind of output, and now we can't just verify, because otherwise this would sit very quietly without any prompting or anything, because in fact when run runs, it's asking some questions. How does it get that output, how does it get that input into the program when we're just verifying something? And so now it's just in open run.out like that, and then outside of that in close like that. So here is we're creating an input file which we are cooking with the answers we want to provide our little program when it's running. And then we're creating an output file where we are just creating what we expect to see. So this is the sort of, this is the example input here, and here's the example output we really hope gets created. And then we actually open the input file here as an input file here. And then when the program is running, we want to verify that the output that we said that we would produce here is actually produced. So we just verify against this output that in fact that's what happens. Let's see how that goes. So go. Oh, never ran the test because it's an untested run. So let's actually run the test. So little red box, like fail on that, didn't like that. So let's try again. And now look at that. So started, ended, it actually passed the test. I provided an Ada for the answer to the first question. I provided a 2 for the answer to the second question. And it all passed. So this little block here proves that I managed to create a little input file and create an output file that I'm expecting to come from the program. Then open up that input and verify against that output, and then run and just see that, well, yeah, in fact, for that input I do get that output, which was my test. Okay, so now I've tested that this I/O happened the way I expected. So for tests, this might be a great way to run tests. I just want to show a little bit of a shorthand thing. These are what you might call temporary files. They're not important in a big sense. They're just, this run.in and run.out are made just for the purpose of setting up a little test, and after you're done closing the test, essentially you don't really care what's in there. This might be nice. I mean, in the end you could go and check that file out and see if the content is what you think it is and that sort of stuff. So that's not a terrible thing. But if it's a simple message sort of thing, then there's a shorthand which I'd like to show how it works. So if we do an in supply like that, so now this sorry, it's not supply, it's provide. So if we provide an Ada followed by, because there's a println up there, an end of line, and then the number 2, and you could put an end of line, actually by default you get one, but I guess just to make it, that's all fine. So provide those things for input there, then that happens all internally. There's no outside file that gets created, but effectively inside of this in provide out to the in close, any input requests are going to go through this stuff and ask for, you'll get an Ada followed by an end of line, so it says like typing Ada, pressing enter, and then after that part is finished you'll get a response of a 2 pressing enter for any other reads that happen next. So so instead of having to set up an external file that's going to be my input file, this in provide is kind of a shorthand for doing that step. And then maybe not surprisingly, then there's an out expect. So if you provide something, then we should expect, in this case, we expect a name, name, and then number. These are the prompts. And then a hello, comma, Ada. And after all that, there's an end of line. And then the next string you would expect is you. Oh, I did, huh. Let's fix that. I'm a terrible speller. You choose 2, follow with an end of line because it's println, and then that's it. So really those are the sort of things we expect, especially let's fix the choose or chose. Yeah, it's chose to. I guess I did right. Chose to. You chose to. Okay. So name, number, Ada, run, close. So let's just end that and try it again now with that test. And it passes. So started, ended right there. So this thing, this version, didn't actually take advantage of these little temporary files. I just have a method here, or a function if you like, that sets up what will future input require here, and out here is what will future output provide. What will we, so let me choose different wording. What will we provide for future input here, and what do we expect out of future output here? And those are all set up as internal files instead of having to save them as little temporary files we're writing to the disk all the time. So this stuff can now all go away. Don't even use that. And that seems simpler. So there's that. We can end that run and try it again. Just prove. Hopefully, yeah. See, still pass the test. Back to asking me questions. So that's good. All right. There's one thing I want to introduce then about this. So when tests are being tested, often things go wrong, and what that means is you can maybe open up an input file and never quite get to down here where things close because of some sort of exception or something like that. Happens all the time. So that's a bad habit, to assume that you're always going to get out of everything and properly close stuff like this. So a better choice is this sort of notation: close, close. This sort of input handle, so maybe in, close that input. And so instead of having to explicitly close it, I can set up this handle called a close. So some name, really doesn't matter what the name is, but this is my input that I'm providing. So close, I want to in the future close this, but first set it up. So in provide this closable thing. And then inside of this block, from this curly to this curly, that closable thing is available. But once I get out of that block, even if it's some sort of an error, like an exception of some sort, it'll still properly close that file, and I don't have to explicitly do it. It's actually done just because it's a closable thing. All right, and so now I don't have to type the close, and it's safer. So I know it takes a little more typing compared to what was in there before, but it's actually a much better version of how to close a file. That's a try with resources block. It's a good thing to just know about in general. So then I hope you expect that if that's true, then that'd be true for this kind of thing. So close out equals out expect. So instead of having to close that explicitly, we can now do the same in there, and it looks more like that. So a little bit more typing to make that look right, and I think this is maybe a better way to format these guys. That's the first line of stuff that gets sent out, and there's the second line of stuff that gets sent out. Okay, so provide those guys, expect that guy when you invoke run. And now there's no explicit close because the try block will automatically close it when it's all done, even if something bad happens, which is better for the purposes of making sure you don't have just leftover junk that you forgot to clean up. So that's the reason why that notation is in the language, and it's a good habit to use. So try block, the curly braces show which blocks, what part of the code that resource should be available in, and then outside of that, so once the code exits this block, then the file's automatically closed. So that's just better, I hope. And now we're back to close that off and run it again. and still passes the test just as before, but now we don't have these temporary files, and we have a better choice, I think, for a lot of resources is these sort of closable things, is to use this try with resources, and if it's closable, the try block will automatically, in the background, just for you, just to save you the trouble, will ensure that those things get closed, even if a bad thing happens. So if you don't actually match up, you get an exception or some error happens, it'll still close the files. So that's good. All right, that's it.